Be examining how drag force affects the net force and examining how Newton's second principle of momentum holds true when there are unbalanced forces and velocity and acceleration change. And this is the video that we'll be observing. Initially, there is an equal weight and tension force, and then the spring is dropped, and then there's an instant when the tension force equals 0, and then an unbalanced force of drag force acts on the spring through the duration of motion. So here's the video. Math and calculations were actually done by GlowScript, and all that was needed was to edit the initial conditions for the position of the ball given by the tracker software, and then it needs a drag constant, which was calculated by a trial and error method, as well as using this drag constant in the later math to calculate the drag force. And that is how the proportionality was calculated, because drag is proportional to the force in the opposite motion, which you can in the first duration split of motion. There is a tension force and a weight force acting on the ball. That is the first part of the video. And once the ball is at the instant where the tension force equals 0, the drag force begins acting on the other direction, which is proportional to the weight force, and the drag force is calculated by the magnitude of the ball velocity with the drag constant squared times the normal of the ball velocity. After we input our net force equation with the weight and the drag force as seen here, we can then run the program by appending an arrow with the weight force, indicating the weight force, and then we can run the program and we can see what our data yields. Here we can see the computer model by the GlowScript of the time versus predicted position, which is a very straight incline slope down the graph. And then you have the observed position from the tracker software, which is slightly more jagged, and this can be due to different drag forces in the air, as well as discrepancies when measuring the position versus the time, which the GlowScript calculations will not make that error. You can see that generally the observed position does follow the GlowScript model, so the experimental matches with the theoretical data. If you were to draw a line of best fit through both of these, it would be very similar. However, in the experiment, what I would change would be more attention to how the tracker software tracked the range of motion, as well as eliminating any other forces, net forces, that could have caused an unbalanced net force equation, which I did not account for.